So we introduced formulas, expressions, which can be used to find potential energy of a system which consists of two charged objects. Like in this case, two point charges, right? So 1, 2, of course, we can use this formula to find potential energy. But what if we have more than 2-point charges? What if we have 3, 4, 5, 100-point charges? How can we find the total potential energy of the whole system, which consists, for example, of 100 particles? So now, back to this, 3 charges. And let me draw their sort of configuration. So the first one, the first charge, let's say, is here, positive. I will label them later. Then there are 2 negative charges. One is here, and one is here. And these 3 charges are at the corners of an equilateral triangle, right? So I can say that, so no, dash line, let me use dash line. So let's say this is L, 3 centimeters. Okay, let me write here. L equals to 3 centimeters. This is also L, and this is also L. So equilateral triangle. And now let me label these charges. Q1 is 1, yeah, 1 nanocoulomb. Then these two minus 2 nanocoulombs. Q2 minus 2 nanocoulombs, and Q3 equals to also minus 2 nanocoulombs. So that is the electrical system, and then some geometry is given, LLL. Yeah, that's it. And now, okay, let me write. So charges given Q1, Q2, Q3, then L. And so what we need to find, which we label the total mechanical potential energy. Just let me write. So U, total PE, potential energy, right? That's reasonably common abbreviation, PE, potential energy, total potential energy. So, and if I don't discuss this problem in the class, usually, as I told you, usually I start getting plenty of emails from students. They don't know how to address this problem. And the approach is simple. We know how to find potential energy of 2-point charges. And now we just need to look at all possible configurations of 2-point charges. All possible. And each of those configurations, possible configurations, are going to contribute one additional term like this to the total potential energy. In this case, how many possible configurations we can have? So Q1 and Q2. Okay, let me maybe use green color. Okay, so first one, it will give us what? Potential energy U12. And that potential energy can be found using this formula. Then Q1 and Q3. Second possible configuration, of course, that is going to give us potential energy U13. And again, that can be found using this formula, of course. Q1 and Q3 must be used. And the next possible pair of charges, these Q2 and Q3, which are going to give us U23, right? So now we just need to add these 3 terms together, and that will be the total potential energy of the whole system. Okay, let me do it. So it will be U, okay, let me add total equals U12 plus U13 plus U23. Of course, some of these potential energies can be positive, can be negative, right? So it depends. For example, these 2 negative charges, of course, their potential energy is going to be positive. But this is going to be negative, this is going to be negative as well. Right? Okay, let me write also. So K Q1 Q2 divided by L squared, and since they're at the corners of equilateral triangle, denominator is going to be exactly the same for all these terms. So plus K Q1 Q3 divided, wait, force of habit. You see what I've done? Horrible mistake. You've never seen you didn't see that square, because I used, of course, the Coulomb's law expression for the Coulomb's law. Then plus K Q2 Q3 divided by L. Okay, so if you plug all the values, I'm not going to do it, you will end up with actually 0 joules. So this term is going to give us, hold it, the same, 1, 3, U2, 3, yeah. So this will be negative minus 0.6 times 10 to the power of negative 6 units of potential energy, joules, just like kinetic energy, work, units of joules. Then minus 0.6 times 10 to the power of minus 6 joules, and then plus 1.2 times 10 to the power of minus 6 joules. The total potential energy is 0. No, happens by accident. It's 0. So now you can see, so it doesn't matter now how many point charges you have in your system. Just see all possible configurations of 2-point charges and add them all up.